Let's start off with my talk on event sourcing. First of all, thanks to everybody for coming, for showing interest in that topic. Just a quick question. Who in the audience has already practical experience with event sourcing? Some, okay. Who has never heard of event sourcing? Okay. Just for me to get a grasp on where to start and how to quick or not quick do the primer of that talk. Okay, let's kick off. Just a quick introduction. My name is Michael Ploed. I work as a consultant, and I've been working on an event source system for a couple of years now. And to start off with a quick introduction to event sourcing. What is event sourcing? What does it mean? And why are there some hard or some tough parts attached to it? Let's take a look at how we would handle data in a classical architecture. I would say this is a rather boring, standard, n-tier kind of software architecture for a backend. And if we want to update some data, we do that on the data set itself in the relational world. Of course, the database keeps its own transaction log and stuff like that, but that is usually not accessible to us as developers. This is, without any doubt, a very successful approach to handling data. We have been doing that for years, and we as software craftsmen and women and architects delivered some really great projects with that approach. But there are some downsides to that approach. The first one is if we need an audit log, for instance, if we need to know who changed what data when, we need to do something. We need to implement that. Yes, there's frameworks and there's solutions to that. We can do that with database triggers. We can do that with AOP mechanisms and stuff like that. But it has to be done. It's extra effort. It is not native to this kind of data handling. The next downside is we don't have a replay mechanism. So we can't say, okay, I have my, let's say, customer management system or my call center system today. There is some nasty bug that arose yesterday somehow. Hey, can I get a data replay to the state of the system for yesterday in my development environment? If we want to have that in the, I would say, classical n-tier relational world, we would have to do a lot of implementation for that to be possible. So usually that's not a case. It can be solved with some database snapshots, but usually this is not a typical approach to solve bugs in these kinds of systems. And if we want to have snapshots, we need to do some extra effort with backups. There has been a lot of discussion recently around two architectural patterns called event sourcing and CQRS. CQRS, for instance, is a pattern described by Greg Young, which says, hey, guys, go ahead and split your application in two parts. One write part, the command part, and a read part, the query part. And CQRS stands for Command Query Responsibility Segregation. So just split this logic in half. We could now go ahead and model these guys up there, the query part and the command part, as independent microservices and also scale them independently of each other. But if we would do that with a, I would say, classic relational storage or some other, if we would just share the data in Mongo, for instance, we wouldn't benefit a lot. And that's where event sourcing comes into play. What we would do in this kind of architecture, we would issue and store events to an event store. And to be honest, there is no typical event store. So it's not something you buy from IBM or Oracle. There is a lot of options for you to use an event. So you can use Apache Kafka in my workshop on Monday, I had a guy using Thrift, for instance. You can use Redis, you can use MongoDB, or you can even use MySQL or an Oracle database as an event store. But the basic idea is that the state of the system is being defined as a sequence of events. Of course, if we do queries against sequences of events, we would obviously run into a lot of performance issues because we would have to recalculate the state of the system for every query. If we count that up into a high volume environment, we'd be dead in terms of performance. Doesn't work. So the next idea that comes into play is that we split the storage also in two parts. We have one main storage, and that is also our legal storage system. So if we are in a legal battle, we draw our data from that storage. That is the event store. But we create a component in that system called event handler. The event handler can either work on a scheduled basis, but also on a pub/sub notification async basis against the event store. It pulls events out of the event store and transforms these events to a new model, a read model, where we read data from. And we put that into read storage. And we have a lot of options technologically there as well. For instance, if our events in the end, our read model, is very graph-oriented, we can use, for instance, Neo4j for the read model. If it is, well, standard document-based data, we could use MongoDB, and we can even think further. We can externalize our read store to a in-memory system, for instance, something like Hazelcast or something else, because if we go ahead and take down the read store, we can recreate it all the time through the events. We just do a event replay. But please don't get me wrong. We just do an event replay. Can take a lot of time if we have billions and millions of events. This is why a lot of systems also work with snapshots in the read store. They say, okay, I have yesterday's pre-processed snapshot, I have the snapshot of last week, and so we can have some points where you can start off with the event replay. So basically, that's the basic idea behind event sourcing. And the query part in the CQS world then goes against the read store. So for instance, for a bunch of events on customers, we say customer registered event, we have a customer verified event, and we have a customer promoted to frequent customer event, and we have a customer deactivated event, which we would model in the relational world as a usual customer table with some statuses and stuff like that. We can create highly optimized data buckets for the view on the customer. It doesn't have to be one customer view. We can, for instance, have a view customers by status. So if I want to get, for instance, the frequent travelers, the senators, I just go ahead and do a map get or a against some map-oriented read data store, for instance. So you can have also a few customers by city. Who lives in Linz? Who lives in Vienna? Who lives in Nuremberg, for instance? So these can be highly optimized, and we can have a really good performance against the read store on the query part. So far, so good. Sounds like, I would say, a very interesting approach to software architecture. And as always, in these kinds of systems, if we talk microservices, if we talk new web frameworks like in the panel today, we had the topic, that sounds easy, that's a very nice thing. No, it's not. This approach is no free lunch by any means, because first of all, you have a vast majority of technological options. What do you use for the event store? What do you use for the message handling? for the event handler, because usually you want to notify for very important events the event handler, hey, do something, there's an important event, you need to process it right away, so that we have a latency in the milliseconds area for the read store. What do we use for the read store? And so on and so forth. So, and there is no event sourcing product out there. And I would say that's good news, because usually these kinds of event sourcing suites, SOA suites, BPM suites, they always have their smell to them. But nevertheless, we have to do a lot as architects and developers if we want to follow that path. The main challenges, apart from the technologies you choose, in terms of patterns and consistency and so on, are, for instance, consistency. How do we handle consistency in this world? How do we validate stuff in this world? Against what do we validate? How can we deal with validation errors, for instance? And how about parallel updates, for instance, to the same entities, to the same, let's say, domain-driven design aggregates? And these three things I'm going to address in the next, let's say, 20 to 35 minutes. Let's talk about consistency. Yes, it's true. Systems based on CQRS and event sourcing are mostly eventually consistent. And discuss that. Yeah, you laugh. Everybody says, yeah, sure. But discuss that with your business. They say, hey, we want unlimited scalability. We want the fastest possible response times, but it has to be transactional to the last bit. If this is really, seriously, your non-functional requirement, maybe eventually event sourcing might not be a suitable solution. But let's take a look at that. The first problem might arise on the way to the event store for the events. That's something where we can run into consistency problems, especially if we have a non-transactional event store, or if we use asynchronous sending of events to this event store. So that's obviously something we have to address if we want to increase consistency. The next part is the event handler. When does the event handler update the read store? Is the event handler able to process, let's say, 1,000 or 10,000 events per second against the read store? How about the sequence of the events? How do we handle that? These are all valid arguments and things we should look into in this system. But if you really want, and I really do not recommend you to do that, but I just want to show you the possibility that you could actually build a, let's say, ACID transactional system with these ideas. It is theoretically possible. Theoretically, because we could, for instance, go ahead and put the read and the event store in one relational database. Put it in an Oracle database, and you can do that. It is possible. You store, for instance, the events as JSON in a table, and then you have some highly indexed lookup tables that are just there for queries that you can update. Possible. And you can wrap some kind of transaction around the operations against these things. So basically, from a perspective, it is possible. Do I recommend you to do that? Hell no, because you will lose a lot of the benefits from event sourcing. My recommendation is go to your business and really discuss with them the level of consistency that you really need. It's, in this case, we are not talking about technology. We're talking about business requirements, non-functional requirements. Yes, the business will say they need that. We've done the discussions all the time, especially those that are have a couple of years under their belts as requirements engineers or software developers with business contacts, of course they tell you. But what I usually do is that I say, okay, we can build the system, but if you really want this kind of scalability, it's going to cost you an enormous amount of money. I always do this discussion around money. I build a couple of options and I tell them, this costs that, and this costs that. Of course, there will be the discussion, oh, the IT is very expensive. Yes, if you want to have a Lamborghini, it costs you more than a simple Skoda. Do you discuss the price of the Lamborghini with the Lamborghini dealer, with the Skoda price? No, obviously not. And what I really, of course, these kinds of discussions lead to nowhere, but what I really recommend is that you work on in a typical domain-driven design fashion manner, on a deeper insight on the business domain, that you tell them, hey, look, this kind of query, it doesn't have to be perfectly consistent at the millisecond. If it gets consistent after, let's say, a couple of milliseconds time or 2 seconds of time, you will not lose any money. And one very important thing is that we need to explain the term eventually consistency there. It doesn't mean that the system will be, if we use our typical German term, eventuell consistent, everybody means, I'm going to run into some sort of a mess. No, it will be consistent maybe at a later stage. It doesn't mean that it will never be consistent. And that's very important. What we can do if we want to improve that, we can easily make the call to the event store transactional. So we can guarantee that the legal set of data gets persisted in typical ACID transactional manners, like this. And another aspect for this kind of discussion is like often people say, oh, a banking system has to be absolutely consistent. Most banking systems are built on this principle. It's the core of their business domain. So that's a non-argument. But basically, there is no standard solution. Go and discuss consistency with your business and show them various options that you have. What I always prefer is say, hey, let's work transactional against the event store. That's possible. There are solutions for that. This problem has been solved. But let's be asynchronous against the update, the event handling, and the read storage. This brings us to a next very interesting part, the validation. Let's take a look at an example domain. We have a user. It has some ID, an email address, and a password, nothing really fancy. We have 2 commands, a register user command and an email address changed command. These commands issue 2 kinds of events, a user registered event and an email changed event. Here's a little best practice on the side of the talk. Always name your events in the past tense. An event is something that has happened in your business logic. So only when, for instance, the verification of the user, the validation of the user has been successful, the event user registered has happened. If the validation failed, the user hasn't registered, so the event didn't happen. Always use past tense and always combine the naming of your events with, again, domain-driven design, the ubiquitous language of your project. It gets a part of the language of your project, the naming of events. So now we have a question here. We process more than 2 million registrations per day. A user can change her email address. However, we have to guarantee that the email address in the system must be unique. How can we do that in this kind of environment? If we work in an ACID transactional world, it's easy, because we can set the isolation level of the transaction to a matter that we can ensure that this doesn't happen. We can work with unique constraints, but we can't do that against the event store. Because where do we validate? What happens? Of course, obviously, we would go ahead and have a read bucket registered email addresses, and if the update, if we have a concurrency issue there, that an email address, for instance, michael.ploed@inoq.com, has already been registered by another colleague with the same name, or somebody's doing some nasty stuff with my email address. So I get a registration, but now there's 2 users with the same email address in the event store, if we calculate the event store. So the questions, of course, if we confront the people setting up the requirements, everybody says, no, that mustn't happen. Absolutely no go. But the question we should be asking ourselves in these environments is, how high is the probability that this validation fails? So there's a couple of things to see here. When can this validation fail? When the update to the event on the read side is a little bit behind in terms of time. Usually, in most systems that I've seen, we're talking about latencies in the lower seconds, higher milliseconds area. So there is usually a tiny time frame where this can happen. Then we should ask our question. So we have, for each data set, a limited time. How high is the probability that we run into these problems? Obviously, not extremely high. Which data is required for the validation? So if we know the data that we need for the validation, we can set up a read bucket in our read store, especially for this validation, and we can adjust the updating of this read bucket to the consistency levels that we need for this validation to be okay. And where do we store the required data? So basically, and the final question, we should always drive that down to business value, to money. That's something that everybody understands. What is the business impact of a validation failure in this scenario? If we really go ahead and look at these things, we find out, okay, yeah, maybe 2 users can't log in. Not nice, but we can handle this. And what is the probability of failure of the system in that area? Most of the times, we're able to handle these kinds of things. Yes, there may be inconsistencies, but they are, if you model your read storage good, rare. Again, the business domain drives the level of consistency here. If we have certain validations that have a high criticality to them, we can address these things by giving them dedicated buckets in the read store and by making sure that these buckets get updated as soon as certain events get fired through publish, subscribe, asynchronous messaging methods. It works. We can solve the problem. So basically, in terms of reading validation data and consistency, we have a couple of options. We can validate from the event store, which is, in my eyes, a very bad idea because it is not very performant. The second, we can perform the validation in the read store. So we set up the mentioned validation buckets, and we are fine. And another thing that I actually fancy quite a bit, especially for critical pieces of data in the read store, is, I would say, something like sanity checks in the event handler. For instance, we can run scheduled sanity checks against certain buckets in the read store, and if we find problems, we can react on them. We can also do sanity checks for certain updates to certain read stores. So if we update a read store, we do a quick sanity check on it with the most important business rules on that store. And we can also react on that and send, for instance, certain events out. Hey, there is an inconsistency in the read store regarding this domain-driven design aggregate data. Please, somebody from the operating team, take a look and clean this mess up. So, again, we can validate from there. We can have special buckets in there. The next interesting piece in our puzzle are parallel updates. Let's take again a look at our example domain. We have again our user with the known commands, the events, and so forth. But what happens when Alice and Bob share an account and both update the email address at the same time? So Alice and Bob started not liking each other. So they get into a fight, and everybody is keen to grab that, for instance, that family Instagram account for their own purposes. So this update happens at the same time. So first question, what would we do in a classical old school architecture? Of course, we could work with pessimistic or optimistic locking on a data set or a row level in the database. Typical features, part of JPA, part of Hibernate, of any more sophisticated persistence framework, works very well, but especially pessimistic locking isn't very good for scalability, obviously. Again here, the locking quality has to be driven by business requirements. Again, it's all about non-functional requirements here. And if we take a look at pessimistic locking in the context of event sourcing, it's obvious that we can't do a realistic, implementable pessimistic lock on a data level in an event source system. That's just not an option. Because we're not storing data sets, we're storing events. Where do I know? And I usually don't want to have a combination on, let's say, an entity or an aggregate ID in the event store. We just take a look at the immutable events there. But what we could theoretically do is that we establish a business lock on the business service side. So for instance, if I implement an application that is handling retail credits. So I apply for a credit because I want to buy a new car. I hand in my papers with my information. They check some SCHUFA or whatever reporting agencies. And then I want to make sure that the credit decision is being isolated from the other users. So I could implement some logic that says, me as banking employee Michael Ploed, I want to take this credit application in my work. So I am working on that, and no other user can work with this kind of data until I'm done with certain steps in my process. So that's a typical business lock. It's not a technical lock. We enforce that with our application logic. Of course, there can be little latencies in terms of updating to the read store, but usually that would work. And that is an established practice in many process-oriented applications. But do we really need a full lock on data? Because if we even take a look at the classical, established, relational, ACID, transactional world, we found out that most of the applications are running fine with optimistic locking. Now, what is optimistic locking? In terms of pessimistic locking, I assume that things go wrong. I'm a pessimist. Things always go wrong. Yes, especially in the microservice world, we say failures are the standard, But in terms of data, on the optimistic locking side, we assume, well, usually these things don't happen, and if they happen, we can deal with them in some other way. So usually we give each set of data a version ID field or a timestamp, and if there is a clash, we tell the user, oh, sorry, somebody mangled with the data, please reload the data into your stuff again. That's basically the idea behind optimistic locking. And that is something we can combine very well in an event source system. So we could go ahead and introduce a version field to the email changed event. So we say, okay, this aggregate ID, this user ID, has a certain version, and we increment that version with every event. So we fire off a user registered event, which creates something like that, and we have a version 0 up there. Then we change the email address and increment the version by 1. We change the email again, we increment the version to 2. And suddenly, somebody is sending me a user for a email changed event with a version 1. Sorry. Doesn't work. The current version is 2. And we do this check, obviously not against the event store, but against the read store. But we can have a highly optimized bucket, which is extremely easy to update. It's a matter of a bunch of milliseconds to take a look at that data. And then we can, what do we do with this event now? There is a golden rule in the event sourcing world, which says never delete an event. So this event is in the event store, it's persistent. And we're obviously not allowed to remove this event from the event store. What we usually do then is fire off another event. The email change has failed. So please ignore this event right there. Another thing that you should take into account, that you should use an event store that guarantees you the sequence of events. So usually, if we take a look at the Redis world, Redis has a couple of, let's say, data storage mechanisms, such as sets, for instance. However, the sets in Redis are, what sets are, unordered pieces of data. And it shouldn't be your task to have a sequence ID on the events. Because, for instance, Redis has a very nice feature, which is the list. And we can always work with the right push operations, for instance, against Redis, to append data to the list. And Redis takes care for the sequence of the events. So these things should be a minimum feature for the event store that you use. You shouldn't be doing this in your application, because you will not have a lot of fun with it, especially in highly distributed environments. Because then you have to face challenges that have been solved in various, I would say, possible event store mechanisms. Again, please drive the consistency from your domain. That is always the golden rule there. You can solve many problems with event sourcing, but please don't assume that these architectures are easy to implement in an afternoon. Yeah, you can get the hello world up and running in an hour or something, but take into consideration that it is an interesting approach, yes, but it adds complexity to your system. And you should, first of all, take a look if you really need this approach. If you have the requirements for it, like independent scalability of read and write processing, highly performant reads, auditing, event replay, and so on, it's an interesting topic, and I suggest that you then take a look into it. So we have, I would say, 5 minutes left before lunch starts. So I would be happy to accept 1 or 2 questions, but I'll be around after that at the conference, and I will share the slides on my speaker deck and SlideShare account. You can follow me on Twitter, @bitboss is my Twitter handle. And I'll also publish the link to the slides, I would say in the next 30 minutes or something, on the hashtag of the conference. Yes, question there. Mm-hmm.
customer with the address.
Yes.
You store his address, and usually the user requires that on his screen he has the actual address.
Okay.
So this is quite
Okay.
quite obvious. From the user perspective, this should be a way.
Yes. How would I deal with these situations? First of all, I would fire off the event to the event store, which is usually in this case, if I have this requirements, a synchronous operation. So I do the synchronous operation on the event store, and then I, for this case, if this is really the requirement, and you just don't want to show the customer, thanks, we've accepted your address change. If you don't want to show the address, then you can fire off a message to a message bus, usually publish subscribe mechanism from the logic after the event has been stored to the store, and you have a handler, an event handler, listening on that queue. And you say, okay, there's an email address changed event. It's in this index of the event store, which is like the unique ID of the event in the event store. The event handler then picks out the address and updates the data bucket that you would load the address from in the read store. Yes, there may be a delay. But do you really need to show, in this simple case, the address that from the read store that has been stored? Why don't you just reuse the address that you just gave him? Hey, thanks, we're processing your request. That's your address, and we assume that things go okay.
So you assume that the thing will go good.
Yeah, because it will usually go good because we've been transactional against the event store. If things don't work well in these, let's say, 0.01% of the cases, for instance, you can still send the user an email after you've detected the failure. Hey, sorry, we had a technical issue. Please change your address again.
From your experience, do you have to bring this asynchronity to the user interface to have some sort of messaging which comes in to say, hey, we had a problem with this step, so exactly what you just explained, you have to build such things?
Well, the user interface should deliver information that is suitable for, I would say, the consistency of the application. For instance, if you have a more complex processing there, and you really want the user to wait until this processing is done, you would obviously show some kind of spinner, hey, thanks, we're processing your request. We're in step 1, in step 2, in step 3, for instance. Typical credit card processing in travel portals, for instance. Then you have to take care of that in the user interface, obviously. But basically, these things, there is no direct relationship to the user interface. It's usually, it's also a good fit for command-based user interfaces that just send out commands to a back-end system, for instance. One last quick question, yeah?
Does it matter, would you say it's better suitable for relational databases or for NoSQL data stores, or it doesn't matter?
Totally.
What's your experience?
Well, I prefer NoSQL data stores for this kind of application, but that doesn't mean that you can't build an event-sourced application with the event sourcing principles with relational data storage. My suggestion is that you use 2 separate database instances. And a nice feature, for instance, in the relational world is the JSON features in Postgres. That's very interesting. Maybe if you really want to stick to the relational world, maybe you want to take a look at that, because what we also want to do is, for instance, we don't want to serialize Java objects as events, like with Java serialization. We would usually prefer some more general form of serialization like JSON or XML or something like that, because then we can reuse these events totally independent of the technology that we use. For instance, if we want to work with, let's say, Ruby as an event handler, we have a problem deserializing the Java objects. Maybe if you use JRuby, it might work, but
So
you know.
it's first more natural with
Yes.
NoSQL stores.
Yeah. Yeah, but it's not. I wouldn't go that far that I say if you use relational storage, this is not event sourcing. That's not true. It's independent of the data store that you use. Okay, so thank you all for coming, for the shown interest. Have a great rest of the conference and a good lunch. Thanks.